All right, let's move for the first talk of the day by Anupam. Uh, so Anupam is a Google developer expert and the founder and CTO of Nebulous Action, a cutting edge consulting company helping organizations navigate their digital transformation journey. With deep consulting experience across enterprise IT, Anupam is a T-shaped consultant broadly skilled across various domains with deep expertise in platform engineering and AI. A strong advocate for Google Cloud technology, Anupam has created several in-demand courses online on platforms like KodeKloud, focusing on Google Kubernetes Engine and automation. Passionate about solving real business problems through design and thinking, Anupam is committed to delivering impactful outcomes and not just outputs. Known for using storytelling to simplify and share technical insights, Anupam actively contributes to the developer community, inspiring others through engaging talks and real-world lessons. So, yeah, let's welcome Anupam. Yep.
Thank you, Sajal. Hey, everyone. Hope everyone had a good bite of pizza. So start by sharing this. Okay, so what we are going to do today is Geshan, who is one of the organizers here at GDK, he had a suggestion for me. So I do a lot of talks around the modernization and AI. He said, let's see, I'll put up a challenge for you. Let's see if you can do a talk on the basics of Kubernetes, explaining what Kubernetes is to everyone, and still keep it technical enough for people to be interested in your talk. So this is pretty much my attempt on doing this. And I was talking to someone just before the event that we are going to be talking about houses and builders, right? So it is not going to be a real estate talk for clarification. It's just an analogy that I'm using to discuss about some of the concepts of Kubernetes. So to start with, let's imagine you're building a house, right? You're trying to build your own dream house. What are the things that you will think of when you are thinking of building a house? You'll probably think of foundational frames. What are the different things that you'll need to create the structure, the frames of the house to build the building blocks? You'll also be thinking about plumbing. What sort of pipes? Where does it go? And you'll also be thinking of the walls that you need to pull in to create the different rooms, and obviously electricity and whatnot, depending on your requirements or what kind of house you want to build. But how does it relate to Kubernetes? So Kubernetes is pretty much the same thing. Kubernetes is nothing, just an orchestrator. It consists of different components. So think of your containers or pods. Pods is pretty much, we'll discuss about pods a bit more in detail in a sec, but think of containers or the pods as the components of your digital house. It can be things like the bathrooms or the house, the rooms, the different rooms in your house. Then Kubernetes is the team of skilled tradies. So what the tradies are doing, they are taking care of different components or different elements within the house, and they are going to build it. They are going to take care of the different components. Plumber is going to take care of the plumbing pipes. Electrician is going to work on the electricity wiring and all that stuff. Then there'll be tiler. Then there'll be, I don't know, a landscaper and a few different people. And then we have GKE, which is Google Kubernetes Engine, that sits at the very top. Now imagine you are building a house, right? You come up with a design. You need 5 rooms. You need plumbing. You need 3 bathrooms. You need electricity, and you need a pool. You need electricity in the pool for the lights and whatnot. So one way is to manage all the tradies yourself. So which is basically orchestrating that work. So you have different tradies that are taking care of their own components, but you are managing it. And Kubernetes is like that orchestrator, the different tradies. So Kubernetes is just an orchestration layer that has different components that are managing different parts of your application. And then they take care of the different components that your application is built on. What Kubernetes Engine is, or any managed service, any managed Kubernetes service on public clouds like GKE, it's like a qualified builder. So rather than you having to manage all the tradies yourself, you hire a builder. You hire Google Cloud. You hire GKE, and GKE does it all for you. It manages all the different components, the worker nodes, the server nodes, the etcds, and the different technical components that are required to maintain and keep your pods and application up and running. So that's basically GKE. So pods is the very basic unit, which is the different logical atomic part of your application, the different services. Then you have Kubernetes, which is the orchestrator, and he's the one that is managing the different rooms, the layouts, or basically all the plumbing. So it is pretty much like the tradies. And then comes the GKE, which is the qualified program manager or the builder who is responsible of getting a qualified designer involved, an architect involved, different tradies involved, a landscaper involved, and you get all your house, which is your application, built as per the standards. Right. So when we talk about Kubernetes, right, so there are three key components. One is the pods, which sometimes people also call as containers. I mean, if we talk about pods, it is always, in most of the cases, not I should say always, in most of the cases, it is 1-to-1 ratio. So one pod pretty much runs one container when it comes to application. However, there can be instances when you have multiple containers running in your pod. And those are the instances when you have something known as sidecar, an extra functionality within that application that needs to be handled for that application to run successfully. And those are the scenarios when you will have multiple containers running as part of one pod. So pod, this is the smallest deployable unit in Kubernetes. Whenever you are deploying applications in a microservices environment on Kubernetes, you're pretty much talking about pods. Now, what are deployments? So deployments ensure that the application run reliably by managing the creation and scaling of pods, right? Handling the updates without downtime, promoting overall efficiency. So deployments is the definition. It is pretty much like the architectural design of your house, which defines how many rooms I need, how the frames need to be laid, what's the height of the beams that are put in, or the pillars that support the level 1 or level 2 in my house, right? So it is like that definition that defines that these are the these many pods I need for this particular application. This is how it should be deployed. And then comes services. Now, services is also very interesting thing and very critical aspect as well when we talk about the microservices architecture. Why is it important? So as we are discussing about the application, the pods, right? So we have a shared infrastructure. We have a number of pods running on a Kubernetes cluster. But if you do not define that okay, let me go back to the house analogy again. So you have, say, four rooms upstairs on level 2 or level 1. And then you have, say, 2 rooms downstairs with a kitchen and a media room. Now, if you do not define how people access those rooms, then it will be worth nothing just knowing that there are 4 rooms upstairs, right? So you need a clear direction and a clear connection between those rooms, which is basically your doors, the connecting walls, how those things are connected. And obviously you don't want the bathroom to be connected directly to your kitchen. Similarly, in your applications, there are few services that you don't want to talk to each other. And that's what you take help from services to define that connectivity, and also at the same time define that isolation, that I don't want these pods or these applications or these services within the application to talk to each other. Or I want this set of 3 applications to be talking to each other. For example, in banking, you will have credit card, you will have loans, you'll have core banking, right? But you don't want those applications to talk to each other directly. However, for a particular customer, if someone is applying for a loan, there should be a way, there should be a connection using which I can fetch the information that how much is the bank balance of this particular customer, or how many credit cards does he hold, to check his, what's the term, the credit check or something, just to make sure that he is capable enough of paying the loan payments, right? So, and that's what the services do. They define the connectivity between the different aspects of your applications, which is pretty much nothing but pods. And it also makes sure that the unintended services, they don't talk to each other. So as I was saying, pods, they are basically pretty much the rooms in our house. So what is a pod? Pod is the basic unit. It is the smallest deployable unit in our Kubernetes cluster, which is nothing but a service of an application or a functionality of an application. Think about Netflix. Netflix is a big platform. It has streaming service. It has billing service. It has, I don't know, maybe a few other services. But if you think of billing and the user data and the movie streaming, right? So these are some of the pods, these are some of the services, these are some of the microservices that are running as part of that platform, completely independent, but still integrated with each other. So it contains one or more tightly coupled containers. As I was saying, in most of the cases, it is one-on-one mapping, one container, one pod, until and unless we have our specific requirement that says, okay, before you can make the payment for this particular customer for this billing cycle, you need to run this one-off task, which is to check which plan he's on before they can make the payment. So in that particular scenario, there'll be another container on that pod that will run that one-off task as a prerequisite, or it can be at the end as well, before the container shuts down or before the service is shutting down, that you need to perform this particular task and then run this application or run this particular service. So now we talked about applications, we talked about microservices, which is basically the pods. Now, what if, based on the traffic, based on the number of users, we have a requirement of scaling up? So let's say when you bought the house, you were just married, right? You were a couple. After a year or two, you have kids. Now you feel like, just 1 room or 2 room, it's not sufficient enough. What to do? So you'll go back to the builder. You'll say, we have a requirement of scaling up. We need more rooms in our house. It's not just like you need a room, you get it, right? So you need a provision to do that. And that's called horizontal scaling in Kubernetes terms. So you have a set of pods running, but there is a lot of traffic that's coming in gradually with time. A lot of people are visiting your website. Your product has, it's a hit, and there is a massive traffic that's coming in. Now you need to scale. So what you do, you add another room, 1 more room, another room, right? And that's called horizontal scaling, which is you are scaling horizontally. You are not changing any specifications of what is actually running. You're just adding more replicas of what is running. There is another terminology that I have not included in this slide here that's called vertical scaling, which is not that often used as compared to horizontal scaling. Vertical scaling means you are scaling the specs of your house. So in that case, I mean, I don't know how to relate it with the house. So it will be pretty much like you are changing the land size or shrinking the land size of your house land, which is pretty much not possible. But in case of Kubernetes, the server that the pods are running on, you are scaling the CPU, the memory of that server. Sorry? You buy the next block or you do a subdivision. Yeah. You get the approval from your council, you subdivide your land, you don't use the other half, you sell it, and there you go. Again, that's scaling down. Now, okay, so that's about adding more resources or adding more copies of your replica. Now, what if you already have few pods running, but some of your pods, again, upstairs, I have 4 rooms, right? One of the room, my kids sleep in. One is our master bedroom. Now, there are 2 more rooms that are not used. If guests come in, what will you do? So 2 rooms are already occupied. So rather than accommodating the guest in one of either your room or your kids' room, what you will do is you'll ask them, you'll put you'll make a setting for them to sleep in one of the guest room or one of the room that is not being used, right? So that is called traffic load balancing. And this is something that we do in Kubernetes as well. With a number of pods running, so there can be a set of pods that are highly utilized or resources that are highly utilized. And there might be few resources that are not utilized at all. So to avoid those kind of situations, what we do is we use something called as load balancer. So what load balancer does, rather than unevenly distributing the load on or unevenly asking the guests to sleep in 2 of the 4 rooms that are available, I distribute the guests or I distribute the number of people that sleep in those rooms. Similarly, in pods, in Kubernetes, you distribute the workload, right? And that is handled by load balancer. There are different techniques and methodologies using which you can distribute the workload in the backend resources. So what you do is you create a virtual layer in front of your resources that run the application, which is basically the pods, and you have a virtual address, a load balancer address, and the traffic hits. So to the outside world, it is the load balancer address that the people see. So if you type something like google.com, right? So it's not just one server that's running up there. You'll have, I don't know, hundreds or maybe thousands or multi-thousand servers running in the back end. Google.com is just a virtual layer at the top. So that is the load balancer. And what it does, based on the traffic, is it from Australia? Is it from US or Europe? It will distribute the load to the respective servers for the optimal performance and availability. Right. Now, as I was saying, deployments, right? So deployments is managing our layout for the house. So anyone who has been involved in building a house here would know that before even start thinking of building the rooms or getting the interiors in, you have to think about and get someone qualified involved who can define what the configuration of the rooms would look like, how high the ceiling can be, how many rooms can you build in that particular space, in the land size that you have. Is it feasible? How wide the walls should be, and many other things like that, right? If you're looking for a pool, that what's the minimum size of the land that you need for the pool? Is it suitable for the builders to put up a pool in your house? Likewise, in Kubernetes world, you have deployments. So deployment is like a definition file, wherein you define that I need these many pods. This is my deployment. And these are the pods that I need running and within for that application, and how many pods I need running. Do I need horizontal scaling? If I need horizontal scaling, up to what size I need that scaling to go? Because it's not just about the performance. You also have to think about the security, right? So when you are building the house, it's not about the fancy doors. You also have to think about, is it breakable, easily breakable? Can people just easily come in? Or so you have to maintain that balance, right? So similarly here, if there is an attack, DDoS, so there's something like DDoS attack, wherein an unwanted attack, unwanted traffic is coming and hitting your site, your URL, or your servers. And if there are so many requests coming at the same time, now there are two possibilities. One, if you don't have enough resources, the application will die, obviously, because the resources, they'll have limit. Or you will have auto scaling, which is like, if you don't put a check on that, it will keep on increasing the number of pods or the applications that run behind that application. And at the end of the month, when you get the invoice from Google, you'll be shocked. You'll be like, I didn't even use it, right? Because your application only needs 10 pods for that application to do the job that your application is supposed to do. However, because of DDoS attack, there were like thousands of pods that were running, and you are probably paying for something that you didn't even use. So it is the definition wherein you define that at any point in time, I want minimum of 2 pods running, for example, right? So which is like, in this size of the land, I need 2 rooms built with the possibility of extending it to 6 rooms in future in case needed, but I don't want to go beyond 6. And that's what something like council approval is about, right? So you prepare a design, you take an approval, you define it that this is the material that we're going to be using. These are the number of rooms that we are planning on using, but we want an approval for up to 6 rooms. So that's pretty much like the definition that you do when you create the deployment file, which is defining the desired number of pods, minimum, maximum, the configuration, the memory, the CPU, and the services, how they should be connected. Now, services is pretty much like defining how the rooms are connected. As I was saying, you don't want your bathrooms to be directly connected to your kitchen, right? So you need a bit of isolation, and that's how you will design your architectural drawing when you are engaging an engineer to design the room structure for you, that this is where I want my kitchen, but I don't need direct access to the bathrooms from the kitchen. This is where the meals room is, and I want the meals room directly connected to my kitchen so that I have a direct access, and there should be a walk-in door or something like that. This is what the services are used for. Just imagine, as I was saying, there are 4 rooms upstairs. But if you don't have a connectivity, if you don't have a direct defined path that how you go to kids' room, then no one will be able to reach or access that particular room. So when you instruct your kids, okay, kids, go upstairs and go to your room. If they don't know that there is a stair that's going upstairs to take us to the kids' room, which is on the left-hand side of the lobby upstairs, they won't be able to go there. This is pretty much the same concept with the services in Kubernetes as well. Now, another important concept, which is pretty much the last one, is jobs. Jobs is what I was talking about as a side container. Jobs are pretty much like one-off thing, right? So things like if you have leakage in your bathroom, right? So you just get it ready, get it fixed. That's one of job. Or you are upgrading your television. It's been long, 65-inch. I don't like it. I need 85-inch or 90-inch, but I want it wall mounted. You get it ready. They just do the job, wall mounted, and off they go. This is pretty much the same concept here. So one of tasks, things like taking up a backup or doing a batch processing or analyzing an analytical data from a data warehouse is a job where you just run a command and it does a job for you and it doesn't keep on running. So that's on a very high level Kubernetes. But then the question comes, what is Google Kubernetes Engine? Where does it stand? So Google Kubernetes Engine, think of it as the master builder, right? So we have been talking about the tradies, the landscapers, the electricians, the plumbers, and the tilers. Now I'm talking about the builder. Why do we go to the builder? Because I'm pretty sure no one here, unless we have a lot of time and we have real passion about doing that, right? See, we don't really want to manage the tradies ourselves. So we'll go to a builder. We'll ask them to do the whole project management for us. We'll ask them to manage the tradies for us. We'll just tell them this is the task, this is the job that we want. And this is pretty much what Google Kubernetes Engine does. So it is a qualified builder to manage your pods, your applications, your Kubernetes clusters that are running. So GKE is a managed Kubernetes service that runs on Google Cloud. It simplifies the Kubernetes management. It handles all the tedious underlying infrastructure management. Now, even in GKE, there are two modes of GKE that are available. One is standard, one is autopilot. Now, standard and autopilot, if I have to, again, think of the builders. So there'll be builders who will say, look, this is the package. We'll just give it to you and you do nothing. This is what you're going to get. And they will manage buying all the supplies and all the materials, all the tiles for you. Then there'll be builders. Okay, we'll arrange all the tradies, but now you tell us what kind of tiles you need, what kind of taps you need, what kind of home appliances you need, right? So you choose everything. And that's pretty much the same concept in autopilot and standard. In GKE standard, you choose what kind of nodes you want. What is the upgrade process? When do you want those nodes to be upgraded? You maintain the worker nodes, which is basically where your application pods are running. The server nodes, the control plane nodes, which is basically the brain of the Kubernetes engine. That's all managed by Google itself, but you still manage the worker nodes, your applications, right? So how the auto scaling should work, when the worker nodes should upgrade. So pretty much like choosing, oh, no, I want this tile, right? I want this sort of appliances. I want these taps to be installed in my bathroom. So in conclusion, the orchestration is the future, the orchestrated future. If you even, so I was in Vegas last month at Google Next, right? So last year, they were talking about Gen AI. This year, they had been talking about agentic AI. It has been all about AI. However, at the same time, they have been talking a lot about the operational upliftment and the improvements around the underlying infrastructure, the Kubernetes engine. But it all ties back to AI. So it doesn't matter whether you are talking about AI or modernization of your application or the servers, right? So there is still the servers, the virtual machines, or I should say the containers, the likes of Kubernetes clusters that are still needed. So even if you are doing a lot of AI work under the hood, if you are someone who likes doing it end-to-end and be across what is happening under the hood in the infrastructure layer, it is pretty much going to be either some sort of container, and most likely it is going to be Kubernetes. So the orchestration is going to be the future. It is the future. It has been the future for the last few years. So it is about orchestrating your modernized applications using the power of containers, right? So Kubernetes are, in a nutshell, orchestrates your containerized application. It helps you define how your application should look like, what it should do, how secure it is, and how good or bad it performs based on the deployments that you define for your security, for your scaling, for your configuration of the pods. And GKE, it just simplifies Kubernetes in the cloud. So under the hood, it is managing everything for you. Again, if you're doing GKE autopilot, it manages the upgrades for you. It pretty much manages the whole infrastructure that is needed for a Kubernetes cluster for you. All you need to do is define what you really want to achieve using your applications and how the applications should communicate with each other. Now, just a quick snapshot of the evolution of Kubernetes, or some of the key Kubernetes milestones before we wrap it up. So in 2014, Kubernetes was launched by Google. And then in 2015, they did the first major release, which included all the essential features and set of foundation for the growth. 2017 is when the Kubernetes 1.6 was released, and they also released RBAC. I think in 2018, Kubernetes 1.12 was released, and they also announced the support for Windows environment. 2021, Kubernetes 1.2 and the stable features. So 1.21 in 2021 marked several features as stable, solidifying Kubernetes reliability and the performance. That's pretty much it. That's pretty much all about my talk. Thank you. Yeah, this is me. If you want to get in touch, as Sajjad was mentioning, I have a online course on Google Kubernetes Engine on KodeKloud. So KodeKloud, if people don't know, it's a DevOps platform. So I have a course on Google Kubernetes Engine. It's a 6-hour course with a lot of advanced hands-on workshop labs as well. If you want, more than happy to connect on LinkedIn. I've put on a QR code there. And I don't think I have to say anything about the introduction, which I already covered. Thank you very much. Thanks for your time, everyone.
Just using load balancer credentials by itself, I just like the card level.
Yeah, that's a great question. Now, so we have been doing it for some time, right? By creating the instance groups. So the whole concept of instance groups was you create a bunch of instances in the backend, and you just have a managed group and put a load balancer there. The challenge with that is the repeatability, the time it takes for scaling, right? Because in the backend, if you node it, try it out, spinning up a Windows machine with a whole bunch of applications and deploying an application as a pod, the time difference that it takes, right? And when you're talking about the scale, wherein you need hundreds and hundreds of pods to be deployed in few seconds, it is going to be a major impact for, think about like Thanksgiving celebrations or the Christmas days, right? So when everyone is hitting the store's website and they need to scale significantly and at a very rapid pace. So that's one thing. Also, in terms of the resource usage, right? So you need a lot of so with the pods, because they are using the underlying infrastructure, they share the resources of the underlying infrastructure. So if some of the resources are not being used, they just scale down, right? So you are not wasting the resources. Whereas in compute or the VM, you need quite a lot of resources dedicated for the internal operations for the operating system itself. Does that make sense? Yeah. And yeah, it also helps in terms of the, as I was saying, with the deployments, you can have a deployment, a definition file wherein you are defining how the containers should look like. And within the same pod, within the same server, you are also defining another dependency and how the services should connect to each other. Yeah, so it is primarily the scale and the resource usage. That's a major benefit of using pods or the containers. Anyone else? Yeah.
I've always heard of Kubernetes is in relationship with Docker. So what is the specific dynamic that they both have?
That's a great question. Look, so this is all about branding, right? So I'm pretty sure people, because Xerox has not been that old. So there was a time when we were talking about the photocopies. We started saying, I need a Xerox, right? So we were not saying, I need a photocopy. So Xerox was what? It was a brand that was one of the first ones to develop a product that can do the photocopies for us. And they were so prominent and so well known. Same is the case with Docker. So Docker is a container platform. It helps you create the containers, but there are a few more other than Docker that you can use to create containers. So Docker is like a container platform. Kubernetes is the orchestrator that manages the containers. It can be Docker and few others. Initially, you might have heard it more because initially when Kubernetes was developed, it only supported Docker. Then as the product evolved, it started supporting other container platforms as well. But they are pretty much two different things. So it is like an orchestration layer, Kubernetes, and Docker is just a platform to create the containers.
So my question is that from a application architecture point of view, so usually like when you're building an application, for example, like the example of Netflix that you give, is it like all the Dockers, they are all managed by one orchestration, like one, so it's like one cluster, all of them are under one cluster, or you have like multiple clusters that are being managed under the same application?
So it doesn't necessarily have to be within the same cluster. That's more of a design question. It all depends on what is the purpose of those containers, right? You will, a lot of time, see multiple clusters in an environment. So like prod, non-prod, and test or development environments. And then again, in the clusters itself, it is more of an architectural design decision that you have to make, right? So a lot of customers, they use shared clusters. The whole concept of shared cluster is you have a cluster and then you have different applications in form of pods running on those clusters, and you separate them out using something known as namespace. So namespace is like creating a virtual boundary, right? Within, so it is like on AWS or even in Google, you have the whole network, but then you create the VPCs, separate VPCs, right? So it is like a virtual umbrella, a virtual canvas that you create. Now it is up to you when you, are you across GCP? So there's a concept of shared VPC in GCP, which is primarily used for all the shared services as in DNS or Windows servers and things like that. Then you have dedicated VPCs for people who just want their separate VPC altogether. They don't want connectivity with anyone else. Same goes with clusters. So you can have shared clusters running multiple services. You can separate it out using namespaces. However, there can be teams. They want their cluster separate altogether. They don't want it to be interacting with anything. And that is predominantly the case with the non-prod, as I was saying, development staging, testing clusters, and then you have prod clusters. You want to separate that out.
One last question, and then Anupam will be still here after the talk, and then you can ask questions if you have.
No questions? All good. Thank you.